All right, welcome back, everybody. We're talking about the periodic table today. 118 elements organized in a very, very specific way. Today, we organize the elements left to right, top to bottom, by something called the atomic number. We're jumping a little bit of ahead of ourselves by saying that the atomic number is the number of protons in the nucleus. And that's really what defines an element, how many protons are in its nucleus. But we'll spend more time on protons on another day. For now, what we're going to do is continue to kind of divide our periodic table into different groupings and ways of understanding the chemical elements. Not only are they organized by their atomic number, but as was true all the way back at the time of Mendeleev, they are still stacked into columns, and these columns represent groups of elements that have very, very similar chemical and physical properties. So the first thing that we're going to do is actually put a name to that. When we say something as a group, we really are talking about columns on the periodic table. And those columns are also referred to as families. Again, because the elements within a column, within a group, have very similar characteristics to one another. The way that we number them, we leave out the bottom two rows of the periodic table, but essentially we're looking at sequential numbering from 1 all the way up to 18, going from left to right on the periodic table. So group 1 contains hydrogen and lithium and sodium and potassium and rubidium, cesium and francium. Group 18 are noble gases, helium and neon and argon, etc. Okay. Again, super important that we understand that represents elements that have similar chemical and physical properties. If they're in the same group, we expect them to have some similarities. The other organizational feature, kind of at a very, very fundamental level, is what we refer to as periods. Periods are rows on the periodic table, and they're also numbered sequentially from 1 down to 7. Again, we leave out the bottom two rows, the lanthanides and the actinides. These periods represent rows. And for the most part, we don't expect that the elements within a period have all that much in common with one another. They might be similar to the elements that are just adjacent to them, but otherwise, they don't have many similarities. They're just placed there based on having similar atomic numbers as we go from left to right. Okay, so those are probably the two most fundamental ways that we organize the periodic table, but there are other things that come or arise out of that. And the first of which is to kind of note the difference between very specific types of elements, metals and nonmetals. There's a staircase that exists on the periodic table. It's right here. And it's really the dividing line of the periodic table. To the left of the periodic table, with the exception of hydrogen, which is right here, we have metals. And to the right of the dividing line, we have nonmetals. So when I think about metals, we're thinking about things that are similar because, they might have similar properties in the sense that they're shiny or that they are good conductors. That's both of heat and of electricity, that they tend to be malleable. You can bend them and shape them. And for the most part, most of them are solids. And typically, those solids have relatively high melting points. There are always exceptions. Mercury is a good exception. It has a low melting point, but most metals have relatively high melting points. So everything that we see on the left-hand side of our staircase those are metals. Most of the periodic table is made up of metals, and there are relatively few nonmetals um, on the other side of the staircase. What you see with the nonmetals is a lot more diversity. Instead of just being mostly solids, when we talk about nonmetals, we typically will see that there are gases, there's a liquid in there are solids. And if I specifically talk about the solids, their characteristics are typically the opposite of metals. They tend to be dull, not shiny. They tend to be bad conductors of heat and electricity. They tend to be brittle, so they will crumble rather than bend like metals do. And they tend to be, when they're solids, tend to have low melting points as well. So there are much fewer nonmetals than there are metals, but their chemistry tends to be very important, and they are elements that we're going to study quite a bit. There's never in chemistry, it feels like, really like easy separation, black and white. There's always some gray. And the staircase, I would say, itself contains elements that are kind of hybrids. They have some properties that are metallic. They have properties that are like nonmetals as well. And we call these elements the metalloids. Sometimes they're also referred to as semimetals. And they have, like I said, properties that are in between. So an example, if I take something like silicon, for instance, it's pretty shiny like metals are, but it's also pretty brittle like nonmetals are. So we've got these hybrid properties that are kind of the bridge between metals and nonmetals. Um, Beyond that, I think the other thing that we typically will do with the periodic table is really talk about um, uh, different groupings of the elements. And in a way, I consider this groupings based on almost how much attention we're going to pay to them. So we have these different categories: main group elements, transition elements, and intertransition elements. The main group elements are the elements that we will pay attention to the most in this class. They have exciting chemistry. They contain metals and nonmetals alike. They consist of the first two columns of metals on the periodic table and the last six columns on the periodic table, which are metals, nonmetals, metalloids. All of them fit into the main group. And in a first year chemistry class like ours, almost all of our attention is going to be dedicated to talking about main group elements. Um, Much less attention is probably going to be focused on what we call the transition metals. And transition metals are right here in the middle of the periodic table, really. These 10 columns of metals. Doesn't mean their chemistry is not important or that we will never talk about them, but we talk about them much less. Those transition metals include some very famous elements like iron and gold and silver and copper and zinc, amongst others. So many elements that you've heard of, no doubt. Um, where we do spend relatively little time at all in a first year chemistry class is with that section of elements that seems to be separate from the others. We call them the transition elements. They're also referred to as the lanthanides, that first row right there, or the actinides. And many of these elements, especially the actinides, are synthetic elements, meaning they were created in a laboratory and not found out in nature. Not as much true with the lanthanides themselves. If you notice where their atomic numbers start, this first one is 57 and 89. They really fit into this section of the periodic table, but the periodic table would kind of lose its nice shape if we put them in there. But if you go on Google, um, you can find examples of periodic tables where they're actually placed where they're supposed to be. They're also sometimes referred to as the rare earth elements, and and they are pretty rare in terms of how much and where you can find them, but they're also rare in terms of how much attention we're going to give to them. So when we come back, we're going to talk about some of the columns on the periodic table that we do talk a lot about, specifically a couple of the metal groups and a couple of non-metal groups. But until then, we will see you soon.